Good afternoon. This is Professor David Koilpillai from IIT Madras. I'm indeed very happy to have this opportunity to interact with the students who have registered for the NPTEL course. The course number is NOC 18 EE29, Introduction to Wireless and Cellular. And this is the first opportunity that we have to have a live interaction session. And I'm very happy to be a part of this and also to be able to answer questions. Also have one of the teaching assistants, Sarthak, with me. You may have seen some responses from him on the discussion forum. Both of us will be happy to respond to any questions that you may have, and also possibly would be happy to take some feedback from you as well. So I hope it has been an interesting course so far. We are now in week 4, and we have covered 19 lectures. And with the first week being more of an overview, hopefully it has given you a chance to get familiar with the terminology that is used in the wireless industry today. Acronyms such as 4G, LTE, WCDMA, those types of terminologies are used. And all of these are the flavors of wireless and cellular communications that we are using every day. So the rest of the course, the remaining 11 weeks, are to focus on the key elements of what makes a wireless system, what makes it challenging to work in a wireless environment, what are some of the differences with respect to the other digital communication systems, and how we can really master the subject so that we can then you can be very good. You can use it as a tool for research. You can also use it as a tool to study more subjects on wireless, and also definitely to work with wireless. So that is the intention with which the course has been designed. I hope it has been interesting so far. We do have weekly assignments, which most of you are doing, and also have been posting a few clarifications. But by and large, the participation in the course has been good. So with that brief introduction, let me pause for a moment. And a few students have shared with us a few questions. I can begin by answering those questions. And but please do feel free to submit your questions online, and I'll keep answering them as the questions come by. So we will now switch to answering a few of the questions that have come to us over the spreadsheet that was shared with you. The first question is from Ashish Verma. The question was just a comment on protocols in wireless. So here, let us see what are the key elements. So the first question on protocols in wireless. Now, if you recall in the introductory videos, in week 1, we saw how a GSM call is made. Okay, so there is the aspects of signaling. Even before a call is established, there's a lot of information that is shared between the mobile and the network, and also the location identification of the network. So there is signaling, and the signaling also addresses the issue of mobility, locating the user, and then informing the user about the incoming call. So call notification. And then finally the call setup, the final step of setting up the call. So we see that there is a lot of information that has to be shared. Call setup is the final stage. So these are what form the protocols. How do two devices talk to each other? How does a device talk to the network? What information is shared from the device to the network? And therefore, we are then able to connect. So protocols are determined and are completely specified. because only if every aspect of the exchange of information is completely known can two devices talk to each other. There must be no ambiguity. So this is completely specified. So for example, if you talk about the GSM protocols, all the different ways in which we can make a phone call, receive a phone call, send an SMS, all of these things are fully specified. Similarly for GPRS, similarly for Edge, then for LTE, then for wideband CDMA, all of these flavors. Now, who determines and specifies this? There is a standards body called 3GPP. Third generation partnership project. This is where the standardization is done. So before a communication can be established, we must have well-defined protocols that are determined and specified and are not changeable beyond that point. So basically, once the protocols are frozen, then we are able to get set up a communication. So this is the purpose of a protocol. This is why protocols are very important. But as users, we may not necessarily worry too much about the protocol, because we are not directly doing anything with the protocol. It's the devices talking to each other where the information is being exchanged, and therefore the ability for us to actually communicate in the call. Okay, so let me move on to question 2. Question 2 is a question that I'm assuming you are a person who's working with a wireless system. It is from Farooq Asma Begum. The question is, what is binary runtime environment? Binary runtime environment. Now, typically, a runtime environment on any device is the executable form. So when you talk about an executable form of a software on an embedded system, then it does rely not only on the main code, but it also relies on several libraries. So basically, it is to do with the executable version of the software with all of the libraries, plus all libraries. So access to all libraries. So this would be your runtime environment. Basically, your mobile phone will have a runtime environment. It will be a runtime executable code. Any device that you work with will have a executable version which you will run when you want to actually use the device. So this is not something that we have covered in the course, but it is something that is part of any consumer electronics, but definitely a cell phone when we talk about it in the context of a device, the software that runs on it, and the environment in which it runs. Shruti has asked another question. This is question 3. What is the key aspect of wireless communication? What is the basic concept? So typically, let me change over to a new page. Any communication system will have the following. It will have a transmitter. It will have a channel and a receiver. Channel and a receiver. Transmitter, receiver separated by the channel. Okay. And we will input information bits, the information that we want to transmit, and at the other end we take out the information bits. Okay, now typically in digital communications, we study about the transmitter, we study about the receiver, we study about the a channel which adds noise to the system. So this is the signal, this is noise. What we get at the receiver is signal plus noise. This is a typical channel that you would have studied in digital communications. However, in wireless, the channel has got some unique characteristics. So basically, I will list out the characteristics of a wireless channel. So it is a unique type of channel, which is why we have a separate branch of study called in wireless communications. The wireless channel has the following features. The first and foremost is that it has the principle of multipath. the signal reaches the receiver through multiple paths, and that is because of the environment in which you are operating. Now, because of these multiple paths, you could have constructive or destructive interference, which will lead to a phenomenon called fading, which means that the signal can go up or down. Now, why is this a problem? Because this is connected to Doppler. Depending upon how fast we are moving, these fluctuations they can be very rapid. So basically, the Doppler, or the speed at which the receiver is moving, can affect us. And then, of course, anytime you have multipath, you could have intersymbol interference. That's another impairment that has to be dealt with. Now, notice that the intersymbol interference is something that is changing fast because of the fading and the Doppler. And of course, the last one, which is very important, is that there is interference also. If you remember, in the design of a cellular system, we talked about reuse plan, and the reuse factor. So, which means that once you have a cluster size, beyond that you will reuse the frequencies, and therefore another cell could be using the same frequencies as you, which could then cause interference. So these are the elements, and of course, any communication channel will also have noise. So AWGN is also present. AWGN, multipath, fading, the effects of Doppler, and the presence of interference. So by this we mean those who are using the same frequencies. So we call it as co-channel interference. So this is what makes a wireless channel unique, wireless channel difficult to work with, and therefore a dedicated branch of study for the wireless channel. Okay, moving on. A couple of students have said they will participate but didn't have questions. But if you do think of some questions, please feel free to raise it. We'll be happy to answer that. The next question was from Mohammed Saqib, which the question was, are there any careers in wireless communications? I would definitely assure you that there is plenty of opportunities, and also very interesting and very attractive opportunities in the area of wireless. Let me just mention a few areas where you could have job opportunities. So opportunities in wireless. Many opportunities, but here is where today in India, we are seeing the deployment of 4G networks. And in the future, this will go to 5G networks. So there is a lot of work that is happening as far as the deployment of cellular networks. That is one area. Now, almost everywhere we go, we are also seeing the deployment of Wi-Fi devices. So again, just the deployment and maintenance of the various wireless networks, several opportunities are there. Of course, within these concepts, there are a lot of R&D jobs that are available. Then also have the emergence of smart cities. I will just give you two examples. One is smart cities and intelligent transportation. And both of these do require a lot of data to be collected in intelligent transportation. And what we find is that, so this is a long list: smart cities, smart grid, all of that. All of these will require data, exchange of data. And this has to be done in a manner that is secure, that is reliable, and it is fast. And it must be easily deployable. Okay, so the system must be easily deployable, and you should not have to do any wiring. So all of these requirements are met by wireless systems. So in the future, when we talk about electric vehicles, there is a lot of data that is being acquired for electric vehicles. All of this has to be communicated wirelessly. So whether you're working in cellular or you're working with the other wireless networks such as Wi-Fi or the various IoT technologies. So there is an entire branch of communications called IoT, Internet of Things, IoT communications technologies. Many new technologies are emerging. If you look at lecture 4 in our course, I would have mentioned several technologies that you could look at. All of these are wireless technologies that are going to be used in the future. So IoT communications, there's a whole area that is present there. Next question. Question 5. This is from Abdul Talib. The question is, what is the wireless communication? Is it communication based on fiber optics? Let me go back to an earlier figure that I drew. The channel in the case of fiber optic communications, that would be an optical fiber. Okay. In our case, there is no guided medium. It is actually the open air. So just like you set up, there's a tower and then there's a mobile, and there's nothing directly physically connecting them except the air. And so basically it is propagation of electromagnetic radiation over the air. So for us, in the context of wireless, it is very different from fiber optics. Fiber optics has got a guided medium. For us, it is not a guided medium. You're just radiating into space, open space, and then you are able to pick it up. So it's a very different set of situations. Again, as we go through the rest of the course, you will see that there are several unique aspects of wireless, and definitely very different from fiber optic communication. There was a question from Shubhangi Chowdhury regarding MATLAB online access. We will be posting some information on the discussion forum. We are working with MathWorks. They as soon as they tell us how you can access it, we will make sure that you have access to that. Next question was from Rajesh Kumar. Why was 200 kilohertz chosen? 200 kilohertz bandwidth chosen for GSM? Very good question. So what we find is that in the context of the transmission of voice over a cellular or a wireless channel, okay, we need approximately 20 kilobits per second. So what we would require is a channel for one user which is at least 20 to 25 kilobits per second, because there is some amount of signaling. So if I add the signaling on top of that, this is around 5 kilobits per second. So per user, I need about 25 kilobits per second. Okay. Now, if you notice that if I just design my channel based on 25 kilohertz, then the next user will be positioned here. I must allow some gap. This is what we call as the guard band, so that we can separate these users. So think of it that you have some number of users. Each of them will require a guard band. What GSM has done has been to take a single carrier, which is 200 kilohertz wide. So basically 200 kilohertz wide, and is supporting 8 users. 8 users. But now, instead of giving each person a dedicated frequency, what we do is 8 users via 8 time slots. The advantages, so this is called time division multiple access. The earlier method that I showed you was called frequency division multiple access. Now, time division multiple access is more efficient. Than in terms of frequency division multiple access, because you don't have those guard bands. And this is one of the reasons why we have chosen to go with a time division multiple access system where you have 8 kilohertz. There are other advantages that you can have, and those we did touch upon very briefly. But let me just mention one question, one advantage. So typically, on the mobile to the base station, this is the time. 8 time slots are present. 1 2 3 4 1 2 3 4 5 6 7 8. Okay, so now if I have assigned this particular time slot to my user, again after 8 time slots the user will get a chance. So basically an 8 time slots on a repeating basis. So this is for mobile to base station. Now the base station to mobile, that is also on an 8 slot TDMA. 8 slot TDMA. Okay, and this also happens on a dedicated time slot, exactly like before, but there is a offset in terms of the time slot. So when the base station talks to you, it does not talk at the same time as you are talking to the base station. It's offset. Okay, so basically the mobile transmits, there is some idle time, and then there is a receiver. So similarly, you can see that this will be the next time the base station will communicate to the user. Now notice the following aspects. This device does not transmit and receive at the same time. So transmit and receive happen at different time slots, happen at different times. Okay, the advantage of that is that when I have an FDMA system, I'm transmitting and receiving at the same time. And this requires a very bulky device in your communications. It is called a duplex filter. A duplex filter is the one that separates your transmit and receive frequency. So a duplex filter is a must for FDMA systems, but GSM systems, notice, need not have a duplex filter because they are able to transmit and receive at different time instances. The other thing, which is, I think, a bigger advantage from the design of a communication system, notice that there is a lot of idle time when the mobile is not doing anything. It's not transmitting, it's not receiving, it is idle. So typically there are 6 time slots when the mobile is idle. Now what can the mobile do during this period? The mobile goes and measures the strength of neighboring base stations. Why would you do that? So during idle time slots, what you do is measure neighboring base stations. And the reason you measure neighboring base stations is so that you can do handoff. In case you become far away from your own base station, measure neighboring base stations, and it is specifically for handoff. Now notice a system like FDMA cannot easily do that because it is transmitting all the time. It does not have idle time, whereas a GSM system naturally takes care of mobility. So you have a lot of time to go in and do measurements, and therefore this is one of the reasons why we want a GSM type system. Okay, so these were the questions that were already sent ahead of time. Let me now move on to the questions that are coming in online. Please, again, feel free to send in your questions. We'll take the time to answer them as detailed manner as we can. Okay, this question is from Rohit Apurva. The question is, what is the difference between signal to noise ratio and carrier to noise ratio? What is the significance of CNR in designing a communication system? So let me label that as question 6. Signal to noise ratio is a ratio of powers, ratio of signal power divided by the noise power. Okay. Now, in many occasions, in fact, almost all of the environments that we will be dealing with, the signal that we are talking about is a modulated signal. So in other words, this is a modulated signal with a carrier, modulated signal. So that is why the term carrier power. So basically, it is talking about the desired signal. So sometimes we call this as the carrier power to noise power. Those are exactly the same, no difference. Okay. The signal power to noise power, the carrier power to noise power, basically CNR, SNR and CNR are one and the same thing. There is really no distinction. What we use in a course when we want to formally look at the definition of systems, we often use the term signal to noise ratio. Okay, so this is what we tend to use. But in practice, a lot of times we don't know what the noise power is. So what we can measure is the received signal power. Received signal power. So SNR is a very good metric for us to tell how good the channel is. But what we can measure is usually the received signal power. Okay, so we measure the received signal power. We have an estimate of the noise power, and the ratio of it gives us the received signal to noise ratio. Okay, so that is the answer to the question that was there. So next question from Walker, 22/7. This is CNR is a carrier to noise ratio used for digitally modulated signals in place of signal to noise ratio. I think that was precisely what I mentioned, that when we talk about a modulated signal, you are looking to measure the signal in the modulated region. Okay. Is there any significance of CNR in designing a communication system as significant as SNR? Because we know that the performance of a system, such as bit error rate, is a function of the SNR, signal to noise ratio. Okay, and this is what ultimately determines the design of a system. So therefore, definitely think of SNR as a target parameter that you must achieve in your design. So if you recall, we did discuss the problem of outage, right? So if this is my base station and this is my edge of coverage, this is the range at which I design my system for coverage. But because of shadowing and other impairments, I may not be able to go all the way to the boundary at some points. In some places, I may be able to go a little farther. Some places, I may go a little bit so if somebody is in this location, that means they will not get adequate signal to noise ratio because of the propagation losses. So this is a situation where this particular user will be in outage. Whereas this particular user is actually seeing a good signal. They can communicate even though they are outside of the range. So this is one of the design elements that we have to worry about. But at the back of our minds, we are always looking to ensure that we maintain a certain signal to noise ratio at the boundary. Okay, so hopefully these are let's move on. From Harsh Sethi, there is a question. Is it compulsory to derive all the formulas that we are using in the 4th week? Let me, for the benefit of everyone, let me just look at the topics that we have looked at in week 4. So question 7 or comment 7. In week 4, this is what we have been looking at. We've been looking at relay fading. What are the characteristics of relay fading, the statistical description, what are the properties. One of the key elements is the bit error rate in fading. Now, this is something that has some analytical steps that are needed, particularly integration. And sometimes the integration is not straightforward. You may have to do multiple steps, substitution. But this is one of the most valuable insights that you can get in the context of wireless communication. Now, when we are operating in a AWGN environment, if I plot bit error rate versus SNR, the performance looks like this. It has a very steep fall. But in a wireless channel, it goes like this. Now, this is a AWGN channel. AWGN channel. This is a fading channel, a wireless channel. Now, why is this? Why do we get a straight line? Why is it that it doesn't fall as steeply as AWGN? Now, these insights we can get only if we are able to derive the results that we have been studying in week 4. So I would say that yes, they may be a little bit difficult, but I would very much encourage you to go through at least what we have covered in the lectures. Please go through and try to look at the implications of what the wireless channel is going to do. How is it going to affect my bit error rate performance? In the future, we will study about methods to improve the performance in a fading channel. First of all, we must understand why a fading channel performs badly. Then we can talk about how to improve performance. So this is, I would say, a foundation for understanding wireless. Now, can I use wireless without doing all these derivations? The answer is definitely yes. Of course, you can use a wireless device, not necessarily having to figure out all of these things. But if you would really like to get insights into the wireless channel, I would very much encourage you to spend the effort needed to derive the results that we are currently working on. Okay. Let me move on. There is a question from Radhika Purandare. The question is assignment 3, plot of per channel capacity versus number of channels used is. As channels increase, the traffic carried per channel increases. Okay, I'm assuming that you are referring to the Erlang behavior. The whole idea that this particular assignment or this particular topic addressing the aspects of trunking. Remember, the key thing that we want to avoid is probability of blocking. That is, that you do not have the call cannot go through. Call basically gets blocked at the origin itself. So this we want to minimize. Now, in order for us to minimize this, we have to increase the number of available channels. So if we want to decrease probability of blocking, we have to increase the number of channels. Now, as the number of channels increases, we can, so supposing I can carry 0.1 Erlang with 1 channel. If I double the number of channels, if we make it 2 channels, it's not 0.2, but it may be 0.24 Erlangs that I can carry. So basically, there is a non-linear dependence, because ultimately what we are saying is I want to keep the probability of blocking at a constant level. So the more number of channels that we have, the capacity increase. Capacity increase. That is a capacity increase in the carried traffic. Carried traffic. This is a non-linear growth. Okay, so as you go to 100 channels, you'll see that the traffic carrying capacity is significantly high. So one of the key things that we always want to keep in mind is that have as many channels available for you to deploy your system, so that you can then get the advantages of trunking capacity. Okay, so trunking efficiency. So that is the underlying principle. I'm assuming that that is the question that you are having. Why is it that the channels increase, traffic carried per channel increases? That is basically because the probability of blocking is kept at a constant level. I have more channels available to me, so that I can actually offer more offered traffic, so that I can still, with the same blocking probability, I can now support more users. So that is the underlying principle. This is what we refer to as the Erlang capacity. And maybe it is very important for us to also make the following statement. This is primarily for voice or circuit-oriented calls, circuit-oriented connections. Okay, what do we mean by circuit oriented? Voice call means one particular channel is dedicated to one user for the purpose, for the duration of the call. So circuit oriented connections. Okay, but now as we have moved from 2G to 4G, in the 2G case, this is circuit switched voice. 2G was circuit switched voice. So Erlang capacity was directly the way by which we could design a system. But in 4G, it is becoming, I'm sure you recognize this, VoLTE. This is voice over LTE. This is a IP application. It is not a circuit switch, it's a packet switched. So we have changed in terms of the way with which we carry voice traffic. So this is a packet switched application. So the Erlang capacity does not directly apply here. It applies more to the circuit switched. Basically, we're trying to understand what is the implication of the number of channels. And all we can say is when we are looking at statistical multiplexing, which is what the Erlang capacity formula is trying to do, the more the number of channels that you have available, the lower the blocking probability will be. Or if you fix the blocking probability, I can allow more traffic to be carried by my system with the same blocking probability. So this is a packet-oriented application. There's a change in which how we carry voice today, but good to know that Erlang capacity still has an important role to play. Good. Any other questions? I think that is the last of the questions that I'm receiving. Any more? Oh, okay. There are more. Okay. There's a question from Chandra Sharma. In a high-rise building, like an apartment, height will be 60 meters from the floor, around G+19. If some site will be 200 meters away from that location, so in that case, whether all persons will get the signal or not? Very, very good question. Now, here is my answer to you. So let me label this as question number 9. Okay, so this is my base station. The base station, as we discussed in the lectures, has a triangular grid on the top, basically for the 3 sectors, and has got antennas. So if I look at the antennas on the base station at the top, the antennas are actually down tilted. Now, why is that? Because the base station is at a height of 25 to 40 meters, and most of the users are on the ground. So therefore, my radiation pattern must be focused more downward. So there is a down tilting of the antenna. Now, if you are at any distance from this site, and let us say you're in a high-rise building, and you are on one of the upper floors, as a problem statement said, you're at a height of 60 meters. Will you get good signal? The answer is no, because what is the amount of radiation that is coming in your direction? It is probably a very small portion of the radiation which is coming in your direction. What is the answer to this? Typically, the cell phone tower must be one of the highest points in an environment. So therefore, there must be another cell tower which operators will set up. Probably they will leave this tower alone, but they will find another building which is of the same height and use that to cover the upper floors. So the answer to your question, very good one. The advantage is that if this down tilt is slightly modified, you can still get a good signal. And the reason you can get a good signal is there is no obstruction. You will get almost line of sight. So if this down tilt can be modified, Okay, so if you can remove the down tilt, let us say that instead of down pointing, you kind of radiate it, more horizontally. Then there's a good chance that you will actually pick up the signal, and you'll pick it up with good signal strength, because you will get almost line of sight, right? There's no obstruction. So therefore, with slight variations in the design of the antenna, how the antenna pattern is radiating, or by changing the height of the base station to a higher building, the coverage issue can be handled in a very nice way. Now, another question from Chandra Sharma: how much coverage will penetrate if we are in GSM technology? Okay, so here is another very important one. Um, Signal penetration into buildings. Signal penetration. So this is a very, very important one. Penetration. Now, regardless of whether we're talking about GSM or LTE, there is substantial loss when you have to penetrate walls, when you have to penetrate any metallic a framework, like you're inside an elevator. There is a lot of attenuation when you have to go through floors. That means you're in a basement and the signal has to reach you by passing through a side wall and a floor to get to you. So these are all things that create a signal loss. Now, it does not matter whether we are using GSM or LTE. This is a function of the RF signal propagation. Okay, so very important to note, RF signal property. However, there is one aspect that is a factor. If I look at GSM, for example, at 900 megahertz, and I look at LTE at 2.3 gigahertz, notice that the LTE is at a much higher frequency, or let us say, or 3.1 gigahertz, a much higher frequency. Now, all of these losses increase as the carrier frequency increases. So this will have lower losses for the same. Going through walls, metallic objects, and through floors, this will have higher losses. Okay, and another important element, in this particular case, I am transmitting a 200 kilohertz signal. In this case, I am transmitting a 20 megahertz signal. So if you think about it in terms of the power that you are transmitting divided by bandwidth, then you can realize that LTE because you're using, let's say, 2 watt of power. In one case, it is being spread over 200 kilohertz. In another case, it's being spread over 20 megahertz. So which means that inherently you're going to face signal quality issues based on distance with an LTE system. So LTE will need what we call as the inter-base station distance. This is called the inter-base station distance. Okay, inter-base station distance, base station distance for LTE is less than for GSM, because GSM inherently has got is transmitting with more power per hertz. It is transmitting at a lower frequency, possibly, and therefore, with a combination of these two, you will find that cell sizes have to reduce when you go from 2G to 4G. If your operator has not introduced new cells in your network, you will find that the quality is not good. So that is an inherent element that you would have to worry. Okay, so there's a question, a suggestion that we should write a little bit bigger. Yes, we will do that. Feedback from Raghavendra. Thank you for good feedback. We're very happy to appreciate for the kind words that you have said. Harsh Sethi, my ongoing call is dropped at a particular region of my travel path. I observed this several times. If I want to study this in detail, what approach should I follow? I'm glad you asked. We will actually plan a assignment that addresses this issue. Now, there is a software called a Network, right? Is that the software name that we used for the assignments um, uh, for measuring the signal strength? Uh, we will let you know. There is I think there's a software called Network 2, which you can download onto an Android phone, which will tell you what is the received signal strength. So I will get the, in fact, I may be able to tell you the exact name. Just give me a minute. I think, let me just give me a second. Yes, it's called Network Info 2. Network Info 2. We actually have an assignment based on this. We'll be uploading it, but since you asked, I will clarify. So this will do a measurement of the signal strength of the following: of your own base station. It will also do measurements on neighboring base stations. So you can also see how strong are your neighboring base stations. Now, the reason you find that there is a signal getting dropped at a certain point, most likely is due to a phenomenon that looks like this. Okay, so you are going in a particular direction. The coverage of this particular base station is up to a certain point. The neighboring base station's signal is not yet good enough for a handoff, but is nevertheless present. So typically, when you come to this point, if you don't have a tower to connect to, the call will drop. Now, typically, what should have been a good design, if you from a network operator's point of view, introduce a third base station that would cover those regions in the corner. So effectively, what you should have done in terms of handoff, and this you can verify if you do measurements using this tool called Network Info 2, that as you are moving in this direction, you will find that the purple base station is becoming stronger. So at some point, the mobile that is moving in this direction will initially is connected to the green base station. Eventually, as the mobile moves, will get connected to the purple base station. As the mobile moves, you will eventually get connected to the other base station. Okay, so this is the phenomenon of handoff. So the reason a call gets dropped is because there is no coverage in that particular area. And the reason I'm saying it's because of coverage issue, because the question says every time it happens at the same place. That's a very good indication. But what can happen sometimes is, let's say I'm very close to the base station and I'm talking to the base station, all of a sudden the call drops. That could be because there is excess traffic on the base station. It's not because of coverage issue, because you were talking and the call was of good quality. Suddenly there was a call drop. That could be because of traffic, overload of the traffic. But if you say that every time it's happening at a particular location, I suspect that the coverage for your particular operator may not be good, or there may be a building that is obstructing. So for example, if you have this one, the radius of coverage is up to here, but maybe there is a building that is blocking. So in terms of the coverage is only to the front of the building. The back of the building is in what we call as a dark area. Okay, so basically there is no coverage. And that could happen. Basically, you have gone in the shadow region of a building, and that could mean that you will not, the call will get dropped in that particular location. So again, do download Network Info 2. Do measurements on your particular base station that you are connected to, and then if you could send us an email, then we'll be happy to discuss with you. So that is an answer to the question from Harsh Sethi. Now, another question from Radhika Purandare. We consider received signal strength indication and BER to characterize the channel. Will there be any change if we consider FER or packet error rate? Excellent question. Let me answer this in the following manner. Now, in the context of GSM, we were looking at it primarily in the context of RSSI and a link between RSSI and what we would consider as an estimate of the bit error rate. I put a hat to saying it's an estimate of the bit error rate or an estimate of the frame error rate. Now, RSSI may not always be a good indicator for the reason what is coming in through your receive filter could be signal. That in that case, it is good. RSSI is a good measure. It could be signal plus co-channel interference. Okay, so co-channel interference. So RSSI, so in this particular scenario, RSSI is not a good measure. For this case, RSSI, let me write a little bit bigger. RSSI is not a good indicator of the channel quality. Not a good indicator of channel quality. And the reason is because, yes, you are getting a lot of signal, but what is coming in is a signal mixed with interference. So in that case, what would be a better indicator? So when interference is present, when interference is present, what should we be looking at? Definitely, if you have a measure of way of measuring the frame error rate or packet error rate. FER is frame error rate, PER is packet error rate. These are the good indicators. So RSSI high, FER low. What does this mean? RSSI high, FER low. FER high. That means your frame error rate is you're getting a large number of frame errors. RSSI high seems like it's a good thing to do, but this means high interference. The channel is not good, so you should try to do something to mitigate. Definitely the role of frame error rate and packet error rate, very important in assessing the channel, particularly when we are talking about interference, channels which have interference. Okay, any other questions? So right now, week 4, we have been looking at multipath fading, looking at what is the impact of multipath fading on the bit error rate. Also looking at how do we characterize these multipath channels. So we will continue in week 5. But again, I'm very happy that we had an opportunity to have this discussion. One more question has just come in from Kanimori Muttu. Can a cellular network and communication done through satellite instead of local base station? Okay. Here is the again a very good question. Let me just draw it by means of a picture. Now we have a satellite that is available to us. Okay, that's a satellite. Now I have a terrestrial network. I have a base station. I can communicate to this base station, and this base station must be connected to the core network. Okay, so basically to the core network. And that's basically the connectivity of all. Now, if I am in a place where my base station has connectivity to the core network through an optical fiber or through some cable, E1 line, then I do not need to go through a satellite. I do not need to go because I'm already connected to the core network, and this core network is connected across India. Every base station of a cellular network is connected. On the other hand, if you do not have this connectivity to the core network, let's say you are in a very mountainous region where the base station is not having good connectivity or it's not possible, or you want to create in a remote location of this, but you want to create a cellular service. So in that case, you have a cellular system which looks like this. There is a base station which is present. You will also have to have a local functionality of a base station controller and some other devices. I'll put it as a dot dot dot. Now this I can connect to a satellite ground station and connect through my let me move my satellite to a more convenient location. Okay, so now I can communicate with my satellite, and through my satellite I connect to the core network. Okay, now for remote areas where we want to provide connectivity, or in the case of, like right now, we are going through a major natural calamity in the state of Kerala. Many parts are affected that there may be no communication. So in those cases, we may be able to temporarily provide local coverage, but the core network connectivity may not be there. We may have to go through a satellite to provide connectivity and provide service in those regions. However, we must keep in mind that there are delays that are involved when you have to communicate via a satellite, because mostly you're communicating via a geostationary satellite. So this is a geostationary satellite. So there are significant amount of delays. So we have to make sure that we are taking into account the impact of those delays when we deploy a cellular system. In normal operations, we would not use a satellite because of the delays involved. However, when there is it's a remote location, or there is no direct connectivity to the core network, then definitely the use of a satellite would be the way to provide connectivity. Okay, let me see if we have answered all the questions. Do you have any questions for my teaching assistant, Sarthak? He's been sitting here not answering any questions. So I would like to get him to answer a few questions. If you have any questions, anything on the assignments, any feedback that you would have, this would be a good time for you to tell us. Of course, you can post it on the discussion forum. We'll be happy to answer that as well. But if not, would like to say thank you for joining. Very good questions that have been asked. And we will do this on a regular basis. We will inform you. And also, if you found this session to be helpful, do give us feedback. Then we can see how we can make this a good way to interact with the students. Okay, a couple of more questions. Really finding difficulty to attend to assignments. So that is why the TAs are available. Please do ask questions. If so, let us say a particular question is you're finding it difficult, that is something that we can definitely help with. Maybe give you some additional explanation, give you some hints on what portion of the lecture to focus on. Those are elements that we can definitely help you. So again, the deadline or the submission time for the current assignments have been extended. So please do take advantage of it. If there are any doubts, please email or post a note on the discussion forum. We will get back to that. Okay, one more question has come in. Is there any significance of GSM 900 band till today? Well, it is there. Pan India, it is there. It is operational. So a lot of times when we go outside of metro coverage, our fallback will be to GSM. So yes, there is a role for GSM 900. It is still very much there. They're talking about refarming GSM 900, basically taking that spectrum and using it for 4G. But I believe in a market like India, there will always be pockets where GSM 900 will be present, because that is the basic technology that we have access to today. Okay, so I think with that, Sarthak and I will sign off. Please do send your feedback, and if there are more questions, email us or post it on the discussion forum. We will try to answer it on a regular basis. Thank you.